Welcome to this tutorial on developing mobile applications with Jetpack Compose. I'm the programming professor, and today we'll be exploring Android's modern UI toolkit that's revolutionizing how we build mobile interfaces. Developing mobile applications with Jetpack Compose by the programming professor. Let's start by looking at what we'll cover in this session. We'll begin with an introduction to Jetpack Compose and its core concepts. Then we'll dive into a practical example by building a Graduation RSVP app from scratch. Along the way, we'll learn how to manage string resources properly, display images in our applications, create professional launcher icons, and configure the app manifest. Finally, we'll wrap up with a summary of everything we've learned and discuss next steps for your Jetpack Compose journey. So what exactly is Jetpack Compose? Jetpack Compose represents a major shift in Android UI development. It's a modern, Kotlin-based toolkit that completely changes how we approach building user interfaces. Instead of the traditional XML-based layouts that Android developers have used for years, Jetpack Compose uses declarative UI code. This means we describe what our UI should look like, rather than imperatively telling the system how to build it step by step. The magic happens through composable functions. These are special functions that define pieces of our user interface. For example, if you want to display text in your app, you simply use the text composable function. Now let's put this into practice by building a real application. We'll create a Graduation RSVP app that demonstrates these concepts in action. To get started, we'll open Android Studio. I'm using the latest Narwhal version 2025.1.1 here. When creating our new project, we'll select the empty activity template since we want to build everything from scratch using Kotlin, which is the default and recommended language for modern Android development. For our project configuration, we'll name it Graduation RSVP and use the package name com.progprof.graduationrsvp. We'll set our minimum SDK to API 24, which corresponds to Android 7.0 Nougat. This gives us broad device compatibility while still allowing us to use modern Jetpack Compose features. Let's examine the core structure of our app. We'll be working primarily with main activity, which is the default activity that inherits from component activity. This is where our app starts running. The real magic happens in our composable functions, which are identified by the @composable annotation. These functions define our UI components. In our example, we have a grad screen composable that displays text using the text composable. Jetpack Compose provides many other composables like buttons, text boxes, and more complex UI elements. Now let's customize our text display to make it more visually appealing. We can modify the text composable by adding various arguments. Here we're adding a font size argument set to 50 scaled pixels. Scaled pixels are important because they respect the user's font size settings for accessibility. You'll notice that the SB might appear in red in your IDE initially. This means you need to import the appropriate unit from the androics.compose.ui.unit package. We can enhance our text even further by adding additional modifiers. The code example shows how to set line height, make the text bold using fontweight.bold, change the color to red, and center the text alignment. Android Studio's auto import feature will help you bring in the necessary imports for these styling options. Understanding Android's resource system is crucial for professional app development. App resources are stored in the res directory and include UI strings, images, and animations. Each resource has a specific structure: a resource type like string, a resource name that you define, and a resource ID that combines these with a dot notation. For example, a string resource named greeting would have the resource ID string.greeting. Managing string resources properly is essential for maintainable and localizable apps. All UI text should be stored in the strings.xml file located in res/values. Each string resource is created using the string element with a name attribute. This approach makes it easy to translate your app into different languages later. You can use special characters by escaping them with backslashes, and you can even use placeholders for dynamic content. Android Studio makes this easy with keyboard shortcuts. Alt+Enter on Windows or Option+Enter on Mac will help you extract hard-coded strings into resources. Here's a practical example of how string resources work in practice. The XML file shows how we define our string resources with names like welcome and RSVP count. The second string demonstrates using a placeholder with %d for inserting numbers. In our Kotlin code, we access these resources using the string resource function. And for the placeholder example, we pass the dynamic value as a second parameter. Visual elements are just as important as text in mobile apps. Drawable resources for images are stored in the res/drawable directory. The WebP format is particularly efficient for mobile apps because it provides excellent compression while supporting transparency. Android's resource system automatically handles different screen densities, so you can provide different versions of your images for various device types. To access these images in code, you use the resource ID format like r.drawable.gradcap. Displaying images in Jetpack, Compose uses the image composable along with painter objects that define how images should be drawn. The painter resource function loads drawable resources from your app's resources. Vector drawables are especially useful for icons because they scale perfectly at any size and are defined in XML. The code example shows how to display an image with a semi-transparent effect using the alpha parameter. Every Android app needs a launcher icon, and these are stored in the res/mipmap directory. Modern Android supports both traditional square icons and round icons to match different device themes. You need to provide versions for all screen densities to ensure your icon looks crisp on every device. Android Studio includes a helpful image asset studio tool that can generate all the required icon sizes from a single source image or even create icons from text. Finally, let's talk about the app manifest. The Android manifest.xml file is like your app's configuration center. It defines your app's package name, specifies any permissions your app needs, like camera access or reading contacts, and tells Android which activity should launch when users tap your app icon. This is done through the launcher category in the intent filter. The example shows how to request camera permission, which would be necessary if your RSVP app included photo features. To summarize what we've covered today, Jetpack Compose simplifies Android UI development by using Kotlin composables instead of XML layouts. We built a practical graduation RSVP app starting with main activity and learned how to manage string resources using resource IDs in strings.xml. We customized our UI with properties like font size and text align, incorporated images and vector drawables for visual appeal, and configured the Android manifest.xml for proper app settings. Your next steps should be to explore more advanced Compose features like state management, navigation, and animations. Most importantly, start building your own app to practice these concepts. The best way to learn Jetpack Compose is by creating something you're passionate about. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.